Hello all, I am Siddharth Kaul and I welcome you to Edupedia World. In this video, we are going to deep dive into date and time class of Matlab. Matlab provides a lot of flexibility and easy to use function to play around with dates and times. The primary way to store date and time information is in date-time arrays. These support arithmetic operation, sorting operation, comparisons, plotting, and allows us to format the way the date and time can be shown. The result of these arithmetic differences are returned in duration arrays. And when we use calendar based function, then it is returned in calendar duration arrays. We can create a date time array that represents say due dates like 19 July and 20 July 2016. So the first one creates a two dates like shown in the first line. In the second, I have changed the date to 21 and 23. So now we have dates of 21st July 2016 and 22 July 2016. So using a t.day, we can change the dates. Similarly, in third, using the t.dot format, I can change the format in which I can display the date. So I have used the month, day and the year. So I will get July, then the date that is 21st and then the year that is 2016. This is how we can represent dates and times in Matlab. Continuing on the same, arithmetic operation on dates and times is also one of the best things about Matlab. Here I am subtracting a randomly created date t2 with our original time. So we have a time of 0600 hours on 21 July and 0700 hours on 22nd July. We are subtracting this from t2, that is 23rd July, with timing 6 hours 30 minutes and 45 seconds. The subtraction will generate a two value array of 48 hours and 23 hours as highlighted. By default, a duration array displays in the format hours, minutes and seconds. We can change this display format of the duration by changing its format property. One can display the duration value with a single unit such as hours. Here in this one, I have changed the duration formatting to hours. We can create a duration in a single unit using the seconds, minutes, hours, days or years function. For example, here I have created a duration of 2 days where each day is exactly 24 hours. So using days function, I have done that. Similar kind of thing can be done using months and years functions. In Matlab, specifying time zones. In Matlab, a time zone includes the time offset from coordinated universal time, that is UTC time, the daylight saving time offset and a set of historical changes to those values. The time zone setting is stored in the time zone property of each date time array. When you create a date time, it is unzoned by default. That is, the time zone property of date time is empty. If you do not work with the date time values from multiple time zones and you do not need to account for daylight saving time, you do not need to specify this property. We can specify a time zone when we create a date time using the time zone name value pair argument. The time zone value local specifies the system time zone. To display the time zone offset for each date time, we include a time zone offset specifier such as Z in the value for the format argument. We can modify the time zone of an existing date time. For example, using the time zone property of T using dot notation, we can change it to say Asia, Shanghai. We can specify the time zone value as the name of the time zone region is in the IANA time zone database. A time zone region accounts for the current and historical values for standard and daylight offsets from the UTC that are observed in the geographic region. We can also specify time zone values as string of form ++ hour and minute or minus hour and minute, which represents a time zone with fixed offset from UTC that does not observe a daylight saving time. Operation on date time arrays with time zones automatically account for time zone differences. We can change the time zone by using time zone property. As shown here, I have converted our time into time zone with +8. So we'll get output like 8 July with some time, 9 July with some time. Setting date and time display format. Date time, duration and calendar duration arrays have a format property that controls the display of values in each array. So when we create a datetime array, it uses the Matlab global default datetime display format unless we explicitly provide a format. We use a dot notation to access the format property or to view or change its value. For example, to set the display format to datetime array, t to the default format, we can type like t dot format and we can pass the value as default. Changing the format property does not change the values in the array. It only changes how they look. For example, these are the shown in the slide are the representation of the same date time value. We have Saturday, that is the day, then the month, then the date, that is 23rd, and then the year, and then time. Similarly, we can have another format like month, then date, and then year, like July 23rd, 2016. Or then we can have date, month, and year, like 23rd July 2016. The format property of date, time, duration, and calendar duration data types accept different strings and characters as input. Shown and summarized in the table are the ways in which we can format our dates and times. So we have values of format like year, month, and date. We get year like 2016 July, and like in value of number like 07, and then date as 22nd. Similarly, we have date, then slash, then month, then slash, then year. Then we have date dot month dot year. Then we have year, then hashtag, then month, then hashtag, and then date, and then hashtag. Then we have year, date, comma. We have like month in text like July. Then we have date, that is 22nd. Then we have a comma, and then we followed by the year, that is 2016. Then we have day, that is the Friday. Then we have the month, that is in July. Then we have the date like 22nd. Then we have the year like 2016, and then we have a time like 212. Then we have like month like July, then time like date that 22nd, then year 2016, then hour, minute, and seconds, and so on. Shown and summarized here are the formats in which we can display duration. So the duration of a year is formatted using character y, that is nothing but number of fixed length years. Fixed length year is 365.2425 days. The duration of a day is formatted using character d, that is nothing but number of exact fixed length days. A fixed length day is equal to 24 hours. Similarly, a duration of hour is denoted by character h, a duration of minute is denoted by character m, and a duration of second is denoted by character s. Shown and summarized here are the ways in which we can display the calendar duration. So calendar duration are again denoted by characters. So the character y denotes a calendar duration in years, that is nothing but multiple of 12 months as a display of number of years. Then we have a character of q that displays quarters, that is multiple of 3 months and displays as number of quarters in the time. Then we have m, that is months, that shows as months. Then we have w, that is weeks, that is multiple of 7 days and displays as a number of weeks. So like in a year we have 52 weeks. Similarly, we have d for days, that shows as days, and we have t for time, that is shown in hour, minutes, and seconds. Generating sequence of dates and time. Like numbers and characters, we can generate sequence of dates and time as shown here. So this is simple. We take a t1 and we take a t2. And then we use a colon operator to create a date time array from t1, starting from t1 and ending with t2. So here I am starting from 1st of July and going to the 5th of July. So on each interval of 1 we get one element. We have first element at 1st of July, second at 2nd, third at 3rd, 4th at 4th, and 5th at 5th. So this is how we can create in a simple way a sequence of date and time. Similar to the previous case, we can generate sequence of date and time with spacing of 2 days instead of a default 1 day. So we use t1 colon calendar days of 2 that specifies a space between each element, and we end it with t2. So we get values as 1st of July, 3rd of July, and 5th of July. Similar to days, we can have spacing of hours instead of days. So to be more specific, here I have done a spacing of 18 hours gap between two consecutive time and date. So we have 1st July at time 8, then we have 2nd July at time 2, that is like 18 hours difference, and then we have 2nd July again at 2000 hours, that is again an 18 hours difference. Then we have 3rd July at 1400 hours, that is again an 18 hours difference. Then we have 4th July at 8. that is 18 hours difference, and again to 18 hours addition to this we get 5th of July at 2. We can use line space as well in this in equally spacing the date and time in an array. So this example shows how to use line space function to create equally spaced date, time or duration values between two specified endpoints. Line space basically creates an equally spaced arrays between 2 points. This function usage has been shown in videos where we worked with numeric arrays. The same thing can be used for dates and time. In the first one, we are using dates where we have specified start date and end date and have used line space to create 5 equally spaced dates in between them. Here start date is 14th April 2016 and end date is 4th August. So using line space, our array becomes 14th April, 12th May, 9th June, 7th July and 4th of August. So as we decided to go with 5 divisions, so we can see that all dates are equally spaced. The same thing can be done for time. So we take the starting time of 1 a.m., ending time of 5:30, and we use line space to create 6 equally spaced elements. So we get 6 equally spaced elements from 1 a.m. to 5:30 a.m. with 54 minutes of gap in between them. So the point of demonstrating the line space function with date and time is to show that Matlab automatically follows the calendar rules when working with dates and time. We as a programmer do not need to take care of it. Using calendar rules in Matlab, we can create sequential dates. The following example shows how to use date shift function to generate sequences of dates and time where they obey all the rules that relates to a calendar unit or calendar based calculation of time. Say for instance, each date time must occur at beginning of a month, on a particular day of the week, or at the end of a minute. This resulting sequence of date time will not necessarily be equally spaced. I am going to start with creating sequence with specific day of the week. So I am going to take today, that is 24th of July 2016, that is Sunday, and create an array with 3 elements using date shift. So date shift is a function that is going to return us with sequence of dates we are telling it to return with condition that all the dates will follow calendar rules. The first input to date shift is always the date time array from which you want to generate a sequence. I have specified day of the week as the second input to indicate that date time values in the output sequence must fall on a specific day of the week. So starting from today, the date shift function will return us the next 2 Sundays, hence completing our 3 elements array. We got 24th July today as a Sunday, then 31st July that is next week Sunday, and 7th August that is next to next week Sunday. Similarly, we can use date shift to generate a sequence of start of month dates beginning from 1st April 2016. I have specified start as the second input to date shift to indicate that all date time values in the output sequence should fall at the start of a particular unit of time. The third input argument defines the unit of time, in this case the month. The last input to date shift can be an array of integer values that specifies how T1 should be shifted. In this case, 0 corresponds to the end of the current month and 4 correspond to the end of the 4th month from T1. So the final result from this comes out to be like 1st of April, 1st of May, 1st of June, 1st of July and 1st of August. Similar to this, we can generate sequences for dates at the end of the month. So I initialize dates beginning from 1st April 2016. I have specified end as the second input to date shift to indicate that all date time values in the output sequence should fall at the end of a particular unit of time. The third input argument defines the unit of time, in this case the month. The last input to date shift can be an array of integer values that specifies how T1 should be shifted. In this case, 0 corresponds to the end of the current month and 2 corresponds to the end of the second month from T1. So the final result for this comes out to be like 30th of April, 31st of May and 30th of June. Note that how only the end dates of each month has been taken. The point to note is that the result produced by dateshift function is not equally spaced. This can be easily understood by using calendar difference function where I have passed the array t and days to know the difference in number of days. So we get difference of 31 and 30 days from the each elements. There is so much that can be done using just dates and times, and so much just in arithmetic of date and time that is literally impossible to cover in one video. Here in this, I am just going to show how arithmetic in date and time works. If you guys want to read more about it, you can do it in Matlab documentation that has about 30 to 40 pages dedicated to understanding the date and time and their arithmetic in Matlab. So here in step 1, I have created a date and time from now that is not associated with the time zone. Again, if you want to read about arithmetic that includes time zone, I recommend reading the Matlab documentation. Next, I have created a date time array with 3 elements each having a space of 1 hour in between them. This I have confirmed in step 3 using the function difference that tells the difference between two elements. Now in the fourth, I have created another array with 3 elements, but this time I am subtracting minutes from it. Let me take a moment here to explain what exactly happens here. Here I have written minutes function with 20 colon 10 colon 40. This says to create an array with 20, 30 and 40 in it. Now what I'm going to do is I'm subtracting this 20, 30 and 40 from our original time. So now we get something like 24 July with time 1723, that is 20 minutes less than the original. Then 1713, that is 13 minutes less than the original. And last is 173, that is 40 minutes less than the original. So the net gap between the time is 10 minutes. In the last, I only used integer array from 1 to 3 that by default adds the date to our original date. So now we have a 25th July, 26th July, 27th July as our elements. So this slide just demonstrates the basic arithmetic that can be done using date and time. There are even more complicated stuff that we can do. We can combine dates from multiple sources, or we can do a time comparison. So that all can be done. So I recommend that if you want to go into that detail, to look into Matlab documentation. Plotting date and times. So basically the image you see here is how the line graph of any data plotted against dates look like. This is nothing different to what we already know. Only difference is that the x-axis is the date. We can manipulate these date ticks. We can change the format of the tick just by changing the date time tick format as shown in the line. This will change the format of the date displayed on the x-axis. So you can see we get days, month and year. Similar to dates, we can create a line plot for duration. Here I have taken a duration of 3 minutes, that is equivalent to 180 seconds. So just like dates, we can have duration printed on the x-axis in a way shown in the code. The code is exact similar to date, only difference being the use of duration tick format that we use to set seconds. Again, these ticks for duration can be changed using the property duration tick format and passing the format we want to show in the graph. So here I have changed the format to minute and seconds. So we start from 00, every 30 seconds we get 0:30, then 1 minute, then 1 minute 30, then 2 minutes, then 2 minutes 30 seconds, and at last we get 3 minutes. Creating a scatter plot with dates and time is little difficult thing, as the scatter function that we use to create generic scatter plot does not take date, time or duration as inputs. But there is a workaround. Using plot function, we can create a scatter plot. Here I have done the same and used the marker symbol O to represent our data. So using plot function, we can create a scatter plot. Using the marker O, we are just highlighting all the points in the plot just like the scatter function. So there are lots and lots of things that can be done using dates and times, and it cannot be covered in a single video. This video will just give you an idea how powerful and well built is the date and time class of Matlab is. This just demonstrates just a fraction of what can be achieved using date and time when used with proper application and huge date time stamped dataset. So this concludes our video on date and time class in Matlab. In the next video, we are going to take a deep dive into structures class of Matlab. So until then, subscribe and thanks for watching.